Chapter 1, Python Basics. In the world of Python, functions form the foundation of most programming tasks. Let's begin with some of the most essential and beginner-friendly functions that every Python user should be comfortable with. We'll start with output and input. The print function is your first friend in Python. It allows you to send text, numbers, or even complex data types to the screen. This is useful for debugging, displaying messages, or simply interacting with the user. Complementing it is the input function, which captures input from the user as a string. These two work together for simple user interactions, like asking a question and printing the answer. Now, let's move on to working with data types and conversions. The int, float, and str functions are used to convert values between integers, floating point numbers, and strings. These conversions are essential when you want to perform calculations on data received as input or format results before displaying them. For example, if a user enters a number using input, it will come as a string, and you can convert it using int or float to perform arithmetic operations. Next, we explore some functions that help with basic math. The abs function returns the absolute value of a number. This is useful when you want to work with magnitude regardless of sign. The round function rounds a floating point number to a specified number of decimal places. When you're dealing with averages, prices, or measurements, rounding becomes especially important. Another helpful function is pow, which takes two arguments and returns the result of raising the first to the power of the second. Let's look at functions that help you inspect values. The type function tells you what data type a variable holds. This is handy when debugging or writing functions that need to behave differently based on input types. The len function returns the number of items in a collection, such as a string, list, or dictionary. It is a fundamental tool for working with sequences. There are also functions that support logical operations. The bool function converts a value to either true or false. This is useful when checking conditions or building complex logical expressions. It helps determine the truthiness of values, especially in conditional statements. Before we finish this chapter, it's worth mentioning the help function. If you're ever unsure how a function works or what parameters it accepts, you can pass it into help and receive detailed documentation right in the Python shell. This function is an excellent resource for learning and discovering new functionality in Python. That concludes this first chapter on basic Python functions. These foundational tools will serve you well as you begin to write your own scripts and explore more complex topics. With these basics in place, you're ready to go further. Chapter 2. String functions. Strings are a vital part of Python programming. They represent text and are used everywhere, from user input to displaying information. Python provides a rich set of built-in functions and methods to work with strings effectively. Let's begin with changing the case of strings. The lower method converts all characters in a string to lowercase, while upper transforms them all into uppercase. These are particularly useful for standardizing user input or for comparisons where case should not matter. The capitalize method changes only the first character to uppercase and the rest to lowercase. If you want every word in the string to start with a capital letter, title can do that for you. Next, we look at functions for trimming and spacing. The strip method removes any leading or trailing whitespace, which is often necessary when working with input from users or reading data from files. If you want to remove only the left or right whitespace, you can use lestrip and restrip respectively. Searching and replacing text is also easy in Python. The find method returns the index of the first occurrence of a substring. If the substring is not found, it returns -1. A similar method, index, behaves like find but raises an error if the substring is not found. When you want to replace part of a string, the replace method comes in handy. It takes two arguments, the substring to search for and the string to replace it with. For checking string properties, Python offers several Boolean methods. The starts with method checks whether a string begins with a specific substring, while ends with checks if it ends with 1. These are useful in conditions and filtering tasks. To determine the type of characters in a string, you can use methods like isalpha, which checks for alphabetic characters, astigit for numeric characters, and sspace to check if a string contains only whitespace. Joining and splitting strings is another core operation. The split method breaks a string into a list of substrings based on a delimiter, with space as the default. This is frequently used to process sentences or CSV data. To go the other way, you can use the join method, which joins a list of strings into a single string with a separator of your choice. Lastly, formatting strings is important when displaying information. Python offers several ways to format strings. The format method allows you to insert values into a string using curly braces as placeholders. This is useful for building dynamic messages. With newer versions of Python, you can also use f-strings, which embed expressions directly inside the string prefixed with an f. This is both efficient and readable. Strings are everywhere in Python, and mastering these functions makes your programs cleaner, smarter, and more efficient. That wraps up our exploration of string manipulation in Python. Chapter 3. Lists and Dictionaries. In Python, data organization is key. Two of the most commonly used structures to hold and manage collections of data are lists and dictionaries. Lists store ordered sequences of items, while dictionaries hold data in key-value pairs. Let's begin with lists. A list in Python is created by enclosing elements in square brackets. Lists are versatile. They can contain numbers, strings, other lists, or even a mix of different data types. The append method adds an element to the end of a list. This is useful for building up a list dynamically as your program runs. To insert an element at a specific position, you can use the insert method, which takes the index and the value to be added. Sometimes, you need to extend a list with multiple items at once. The extend method takes another list or iterable and adds each element to the end of the original list. This is different from append, which would add the entire list as a single element. Removing elements is also straightforward. The pop method removes and returns the last item in the list, or an item at a specified index. If you want to remove a specific value, use the remove method. To clear a list entirely, use the clear method. To find out how many items a list contains, use the len function. You can sort a list with the sort method or reverse it using reverse. Keep in mind that sort modifies the original list in place. If you need a sorted copy without changing the original, the built-in sorted function is the better choice. Accessing elements in a list is done using indexing. Indexes start at 0, and negative indexes count from the end. For more complex operations, slicing allows you to extract sublists. For example, using my_list 1 to 4 gives you the second to fourth elements. This is useful when you want a part of the list without modifying the whole. Now, let's turn to dictionaries. A dictionary in Python is defined using curly braces, with each element consisting of a key and a value separated by a colon. Dictionaries are unordered, but very fast for lookups. The get method retrieves the value associated with a key. If the key is not found, it can return a default value instead of raising an error, which makes it safer than direct access. You can add or update dictionary entries by assigning a value to a key. To remove an entry, use the pop method with the key, or use del to delete a key-value pair. If you want to remove all entries, use the clear method. To explore the contents of a dictionary, the keys method returns all keys, values returns all values, and items returns key-value pairs as tuples. These are especially helpful when looping through a dictionary using a for loop. Dictionaries also support dictionary comprehension, a concise way to build dictionaries using expressions inside curly braces. This can be a powerful tool for filtering or transforming data. Both lists and dictionaries are essential in Python because they provide flexible ways to manage collections of data. Lists are ideal for ordered sequences, while dictionaries shine when you need fast lookup and mapping between keys and values. With these tools at your disposal, you're ready to manage data more effectively in your Python programs. Chapter 4. Loops and Conditionals. In programming, decision-making and repetition are fundamental. Python provides powerful structures for both, conditionals for making choices, and loops for performing actions repeatedly. We start with conditionals. The if statement is used to check if a condition is true. If it is, the block of code underneath is executed. You can extend this with elif, which stands for else if, to check additional conditions. If none of the if or elif conditions are true, the else block can be used as a fallback. Python uses indentation to define blocks of code, so it's essential to indent correctly after each conditional line. Conditions are built using comparison operators like equal to, not equal to, greater than, less than, and logical operators like and, or, and not. These allow you to build complex logic with multiple parts. For example, you might check if a number is greater than 10 and also even, using and. Moving on to loops, we begin with for loops. These are used to iterate over sequences like lists, strings, or dictionaries. In each iteration, the loop variable takes the value of the next item in the sequence. This is useful when you want to perform an action on every item, such as printing them, modifying them, or checking conditions. The range function is often used with for loops to generate a sequence of numbers. For instance, range 5 generates numbers from 0 to 4. You can also provide a start and stop value, and even a step value to control how the sequence is created. This is useful for looping a specific number of times. Another important loop is the while loop. It continues to execute as long as the condition remains true. This makes it useful when the number of iterations isn't known in advance. However, you must ensure that the condition eventually becomes false, or the loop will run forever. To control loop execution, Python offers break and continue. The break statement exits the loop entirely, skipping any remaining iterations. It is commonly used when a condition is met and further looping is unnecessary. On the other hand, continue skips the current iteration and moves on to the next one. This is helpful when you want to ignore certain values during looping. Loops can also be paired with else blocks, which are executed when the loop finishes normally, without a break. This is a lesser-known feature of Python but can be handy for certain logic, such as searching and confirming whether a value is found. Nested loops and conditionals are also possible. You can place a loop inside another loop, or a conditional inside a loop. This allows for more advanced logic, like checking for duplicate items in a list or building patterns. Mastering loops and conditionals is key to writing dynamic and intelligent programs. They form the control flow, the logic that determines what your code does, and when it does it. With these tools, your programs can adapt, repeat, and make decisions based on any input or scenario. Chapter 5. File Handling. File handling in Python allows your programs to read and write data to the file system. This is a key skill when working with logs, reports, configuration files, or data storage. To open a file, Python uses the built-in open function. It takes the file name and the mode as arguments. The mode can be R for reading, W for writing, A for appending, or X for exclusive creation. You can also add B for binary mode and T for text, though text is the default. When a file is opened, you can read its contents using methods like read, which returns the entire content as a string, or readline, which reads one line at a time. The readlines method returns a list of all lines in the file, which is useful when you want to process the file line by line. To write data to a file, use the write method. If you need to write multiple lines, you can use writelines, which takes a list of strings. Note that writing in W mode overwrites the file, while a mode adds to the end of it. Always close a file after opening it, either by using the close method or, preferably, with a with statement. The with open as file structure is safer and cleaner. It automatically closes the file when the block finishes, even if errors occur. Python also allows you to work with file paths using the OS and pathlib modules. You can check if files exist, rename them, or create directories, giving you complete control over file operations. Reading and writing files makes your Python programs far more powerful, allowing them to persist data across sessions, log activities, and communicate with other systems. Chapter 6. Error Handling. Errors happen in every program. What matters is how we handle them. Python provides a structured way to manage exceptions using try-except blocks. The try block contains the code that might cause an error. If an error occurs, Python skips the rest of the try block and jumps to the except block. This prevents your program from crashing and gives you a chance to respond to the problem. You can catch specific exceptions by naming them, like zero division error, file not found error, or value error. This allows your program to handle different issues in different ways. You can also use a generic except block, but it's good practice to catch specific errors when possible. To handle more than one error, you can use multiple except blocks. You can also catch multiple exceptions in one block using a tuple of error types. Python also supports the else and finally blocks with exception handling. The else block runs if no errors occurred in the try block. The finally block always runs, whether or not an error occurred, making it ideal for cleanup actions like closing files or releasing resources. Sometimes, you might want to raise your own exceptions. Python lets you do this with the raise keyword. This is useful when you're writing custom logic and need to enforce rules or signal problems. Handling errors makes your code more robust, professional, and user-friendly. Instead of crashing unexpectedly, your program can explain what went wrong and recover gracefully. Chapter 7. Object-Oriented Programming. Object-Oriented Programming, or OOP, is a way of structuring code using objects, which are instances of classes. A class defines a blueprint for creating objects that bundle data and behavior together. To define a class in Python, use the class keyword followed by the class name and a colon. Inside the class, you can define functions called methods, and variables called attributes. The _init_ method is a special method that runs when a new object is created. It's typically used to initialize the object's attributes. An object is created by calling the class like a function. You can then access its attributes and methods using dot notation. For example, if you have an object dog from the class animal, you can call dog.bark or access dog.name. OOP promotes encapsulation, which means keeping the data and the operations that affect that data together. This makes your code more modular and easier to maintain. It also supports inheritance, where one class can inherit attributes and methods from another. This allows for code reuse and helps create hierarchies of related classes. Python also supports polymorphism, where different classes can implement the same method in different ways. This lets you write flexible code that can work with different types of objects through a shared interface. Using UP helps you write clean, organized, and reusable code. Whether you're modeling a bank system, a game, or a network of sensors, object-oriented design lets you think in terms of real-world entities and their interactions. Summary: strings. str.lower converts all characters to lowercase. str.upper converts all characters to uppercase. str.title capitalizes the first letter of each word. str.capitalize capitalizes the first character of the string. str.strip removes leading and trailing whitespace. str.lstrip removes leading whitespace. str.restrip removes trailing whitespace. str.replace old, new replaces occurrences of a substring. str.splitsep splits the string into a list by a separator. str.join iterable joins elements of an iterable with the string as a separator. str.findsub returns the lowest index of the substring or -1 if not found. str.indexsub like find, but raises an error if not found. str.countsub counts occurrences of a substring. str.starts-with prefix checks if the string starts with the given prefix. str.ends-with suffix checks if the string ends with the given suffix. str.isalpha returns true if all characters are alphabetic. str.isdigit returns true if all characters are digits. str.isolnum returns true if all characters are alphanumeric. str.ispace returns true if all characters are whitespace. str.fillWidth pads string on the left with zeros to reach a given width. A list of common Python list functions and methods. LenList returns the number of elements in the list. List.appendX adds an element to the end of the list. List.extendIterable appends all elements from the iterable to the list. List.insertIx inserts an element at the specified index. List.removeX removes the first occurrence of the specified value. List.popI removes and returns the element at the given index, or the last item if no index is specified. List.clear removes all elements from the list. List.indexX returns the index of the first occurrence of the specified value. List.countX returns the number of times a value appears in the list. List.sort sorts the list in ascending order, can take a custom key or reverse. List.reverse reverses the elements of the list in place. List.copy returns a shallow copy of the list. SumList returns the sum of all numerical elements in the list. MinuteList returns the smallest element in the list. MaxList returns the largest element in the list. List.startStop returns a slice, sublist, from the list. List.startStopStep returns a slice with a step value. In checks if an element exists in the list. For item in list, iterates through each item in the list. List comprehension creates a new list based on existing list with an expression dictionary. LenDict returns the number of key-value pairs in the dictionary. DictKey returns the value associated with the given key. Dict.getKey default returns the value for the key, or the default if the key is not found. Dict.keys returns a view of all keys in the dictionary. Dict.values returns a view of all values in the dictionary. Dict.items returns a view of all key-value pairs as tuples. Dict.update other_dict updates the dictionary with key-value pairs from another dictionary. Dict.popKey removes and returns the value for the specified key. Dict.popitem removes and returns the last inserted key-value pair. Dict.clear removes all items from the dictionary. Key in dict checks if a key exists in the dictionary. Dict.setDefaultKey default returns the value of the key, and sets it to default if the key doesn't exist. Dict.copy returns a shallow copy of the dictionary. For key in dict, iterates through each key in the dictionary. Key value for dictionary comprehension to create a dictionary dynamically. Sets set creates a new empty set. A, B, C creates a set with initial elements. Set.addX adds an element to the set. Set.removeX removes an element from the set, raises an error if not found. Set.discardX removes an element if it exists, does nothing if not found. Set.pop removes and returns an arbitrary element. Set.clear removes all elements from the set. X in set checks if an element is in the set. Set.unionOther returns a new set with all elements from both sets. Set.intersectionOther returns elements common to both sets. Set.differenceOther returns elements in the set but not in the other. Set.symmetric_differenceOther returns elements in either set but not both. Set.issueSetOther checks if the set is a subset of another set. Set.issuePerSetOther checks if the set is a superset of another set. Set.copy returns a shallow copy of the set. Tuples tuple creates an empty tuple. A, B, C creates a tuple with elements. LenTuple returns the number of items in the tuple. Tuple I accesses the element at index I. Tuple.countX returns the number of times x appears in the tuple. Tuple.indexX returns the first index of the value x. X in tuple Checks if an element exists in the tuple. For item in tuple, iterates through each element in the tuple. Tuple slicing, returns a portion of the tuple using start-stop step.